students, here we'll be seeing how do we interface a DC motor to the 8051. As we know, we'll be connecting the power jack and RS-232 cable to the microcontroller by default. Now since I'm using this to control a DC motor, I'm supposed to interface this to a target, that is a DC motor kit here. So DC motor kit, you can see there is a power supply, okay, to the DC motor, and the another interconnect to the DC motor is the FRC. As we already know, we'll just match that notch here and insert. So the DC motor is connected to the microcontroller. I'll just insert so it gets locked automatically. So these are the connections, simple connections. One is your power cable, the other one is RS-232 and FRC. The other end of FRC should be going to a DC motor, and DC motor is connected to the power supply. This much is the connections. Now how do we write the program? And writing a program, the logic of the program we already know. So I'll basically type the program, save it as .c. Okay, you can give any name. I have saved it as .c here. After that, I have gone to the project, added that file to the project. The process we know, creating a new project, defining the target, whatever the IC number is specified here on the board. Then taking a new file, typing the file, save it as .c. Then going to source group, go to add existing file to source group. From there, I have selected the file which I basically saved. So now this is the program I basically have. As a preparation, I'll just compile it once to ensure I do not have any syntactical errors, and also I'll check the logic of this program. So as of now, I'm having 0 warnings and 0 errors here. That means the program is good to go. Now, earlier what we were doing, we were directly going for build rebuild to see the result there. But here, since we are having a target to be, hardware included, I am going for options for target. Okay, you can see here we have a tab called as options for target. We'll click on options for target. In that, I will be going for a target option here. I'll be going for a target option here. So in target, you will have to see what is the speed of the microcontroller. On the microcontroller, it is written there 11.0592 megahertz. This is what I have specified here, extra frequency 11 megahertz. And we already know microcontroller has two memories, RAM and ROM. RAM is basically used for storage of data. ROM is used for storage of program and few permanent data. So I want to write the program, whatever I wrote it here, into ROM of microcontroller. So I'm using it as use on chip ROM here. This is the first step of setting. Next, after this, I will just go to last but one option here, debug. Once I click there, you can see it has two bifurcations. One is simulator part, the other one is a driver part. If you want to see the result here on the computer itself, run the program and see here, we'll use the simulator part. If you are using the hardware here, I will use hardware part. So I'll click on use, drop down. You will have many drivers. Along with our microcontroller, the driver what we got is Keel Monitor 51. This is the driver we have in our basic lab, basically in our lab. So click on that. From where my logic starts? My logic starts from main. I'll just repeat this process of setting. I'll go to options for target. There under target tab, I will define the frequency. Check use of on chip ROM. Then go to debug tab. You have to go to driver part. So second part of the window, use. From the drop down, select Keel 51 driver and check on run to main, because from there the actual execution should start. So after that, click on OK. Okay. Once you have clicked on OK, now we will have to do the process of turning on. Now we have to keep our hardware ready. So I'll keep the hardware ready. I'll turn on the hardware. Now you can see a display here. What is it is from ESA company, MCB microcontroller board 51. The version of this board is 1.03. You can see it here. So and your motor is also running. Okay, as soon as I keep it on, the circuit is complete, closed loop, so motor will start running. Okay, once the motor is running, go to compile, build, rebuild and debug. Once you have come to debug, you can note here the motor is running at the maximum speed. If I go to run now, I'll click on run, you people can note the speed of the motor is reduced to half. Okay, because I'm starting the motor with the speed of 7f, half of the maximum speed. Then I will use 2 pins as definition here, 3.2 for increase, 3.3 for decrease. So you can see the speed of motor is decreasing and the speed of motor is increasing. As I press it, it is slowly increasing and it is slowly decreasing. Once again, if I press on reset, it comes back to the maximum speed. Once I press reset, it indicates the program is now erased from the ROM. Now the microcontroller is as good as a new one, and you can use it for the next purposes. So I press reset, the motor is running at the maximum speed. Okay, so you will stop debugging, come back to the original position, and you can conclude this experiment is concluded.